Hi, this is Jacob from the Gitaly team, and I'm with Christian and James, and we're going to talk about what we learned looking into Git packfiles and bitmaps and whatever we can do to accelerate Git clone on the server side. Most of the material for this, or the basis for this, is this issue, Gitaly 1614, and so maybe I should take a step back and say where that issue came from. A while ago, I had an idea on how to accelerate Git clones by using a prepared packfile on the server and transparently gluing that together with a packfile with the latest objects that are needed for a clone. And I did a little demo of this, and I got people excited about this. And then a little while later, I realized that this idea didn't work because packfiles have a uniqueness constraint. An object is only allowed to occur once in a packfile. And I was taking two packfiles that might individually each satisfy the uniqueness constraint, but then when you glue them together, you could get a duplicate object. And that's where issue 1614 started. So that is the realization that this problem exists. And then I started exploring if we can do something about that. And so if we could find a way to still have a packfile we reuse and make Git do less work for the rest of the clone, to see what that would take. And that involved getting deep into packfiles and bitmaps, because the first thing I noticed was that bitmaps seem to make a difference, packfile bitmaps seem to make a difference for avoiding this problem. So that's the starting point. And where it all ends is that I was getting the feeling that things were getting way too complicated, and the rabbit hole was too deep, and I didn't think that this particular thing was going to go anywhere, which we may revisit later. And what I did find out was that so the reason this started was because we observed that GitHub seems to do something where they're reusing packfiles, and we were wondering what this was. And I think I did figure out what that thing is. So I actually want to start by showing that, because that is a nice outcome. Although there's immediately a rainy side, because the way we create packfiles, we can't use this, but I just want to start by showing this because I think it's the most fun part. Are we okay with that, with going into that topic first?
Yeah.
Okay. So, yeah, it turns out that there is an optimization baked into Git already, where if you have a bitmap packfile, and if somebody is doing a clone, and if a large part of that packfile would be sent across the wire anyway, then Git stops looking at some point and just sends a lot of that packfile as is. And the thing is that when you do that, normally you don't, now that I know this exists, I see this happening all the time. So let's, but normally we don't see it. So what I did about that, let me share my terminal, is that I made a little patch in Git that prints a message if there was packfile reuse. And so normally you don't see this message, but this mechanism still works. And so if we want to see that in action, I have a clone here of GitLab CE that is a mirror clone. So that contains both things that normally get cloned and things that normally don't get cloned. And then I have a smaller clone that is just branches and tags. And this optimization normally only kicks in when you clone branches and tags. So if I now, let's see, if I do Gitaly debug on the normal one, you see something like this. And this takes a while because my little computer now has to think hard. So you can see it goes through enumerating objects, counting objects, compressing objects, and you get a message that shows how many objects were sent and how many were reused. Now, the funny thing is that if we do that on the clone, where I'm doing this all backwards. So in the big clone I have over here, if we look in the objects in the pack directory, we see that there is a pack file of 1 gigabyte, and I made a bitmap. And this pack file is big because it is not just the normal clone data, but it's also all the unreachable. It's some of the unreachable data that the client could clone if they wanted, but they normally don't. And things are even worse on the GitLab server because there is data in the pack file that the client is not allowed to clone, but that is in the pack file anyway. And normally after you do a clone, you see something like this. You would see a 600 megabyte pack file. And that is just the data that's reachable from branches and tags. And this optimization that I'm talking about, the pack file reuse that is built into Git and is there all the time already, has to do with how many percent of the pack file we're reusing in terms of number of objects. But size, I'm now using size as a proxy for number of objects. In this case, when we have a smaller pack file that only contains data that the client wants, and when that pack file is covered by a bitmap, then this optimization kicks in. And just to show you what that looks like, it still takes a while. But you don't even see the counting object stage. And my message here is printing saying that we reused 1.5 million objects. And the other interesting thing here is that you see reuse 0, delta 0. That's the thing I started recognizing now. So you're never going to see this if you clone from a GitLab server, or you're rarely going to see this because usually people use merge requests and we create all these unreachable objects that end up in the pack. And then the ratio of normally reachable objects to not normally reachable objects gets skewed, and this optimization no longer kicks in. Because this optimization is built around a rather arbitrary number in the pack bitmap file. Where are we?
Are you trying to show something?
Am I not? Oh, sorry. Yes, I am trying to show something. I'm going to share my whole screen. This always goes wrong. Now we're in a different terminal window. Can you see the new terminal window?
Yes.
Yeah, thanks for saying something. So I'm now looking at the Git source code and at the packbitmap.c file, where there's this function reuse partial pack file from bitmap, which is the optimization I'm talking about. And this has this threshold where it only kicks into reuse if we're reusing 90% of the pack file. So this is one reason why this optimization never kicks in on a GitLab server with a busy repo, because the part that is reachable during a normal clone is less than 90% of the objects. And you see this, so that is one part of the problem. And you can sort of, I want to see how bad the number really is, because in the case of GitLab CE, it's 1.5 million objects if you do a normal clone. And I want to see how many objects there are in that pack file of the full clone. So there it says pack 002, and then there's 1D, D19D. How much is that? 0x1D, D19D. That is 1.9 million. So, and on the GitLab, the actual copy of GitLab CE that we're cloning from on GitLab.com is going to be even bigger in terms of objects. So you have 1.9 million objects in the pack file, and the what goes to the client is 1.5 million objects, and that is well, 15 over 19. Come on. So we're at 78% and not, so which is below 90%, so this isn't kicking in. And there's a second reason why this thing cannot kick in, and that is that it wants to send a contiguous section of the pack file. And if your pack file contains objects that are no longer reachable, then you get a hole, and then this optimization says no, and it no longer happens. So yeah, I'm kind of glad that I now finally understand how this thing works. And I think I also know why we see messages from GitHub that talk about pack reuse, because I think they're basically logging this. They're just creating a nicer message, because normal Git only prints this message. And in the case of GitHub, you see an extra message here at the end that contains roughly this information.
I wonder if that's, it sounds like they've made some changes to Git itself in order to add that output. So I wonder if there are other changes that they've also made.
Could be, but it sounds like this is a fairly simple change, because it's about printing statistics output. It doesn't change the behavior. It's just about, I mean, it doesn't make the system faster or slower or more efficient. It just changes how much you see on the client side.
Does this indicate that they're, rather than packing everything into a single pack file, that they're doing some sort of like pack file splitting in some clever way?
Yeah, so this is an idea that I threw around in that issue. We can get this effect even in our situation where we have 1.9 million objects if we split them. And let's see if I remember correctly how to do that. What I want to do then is create a new clone, git clone, mirror of the big one I have here. And I want to make that the split.
Side note, while you're typing this command, maybe it would be helpful if it was possible for us to, or like, get access to a complete dump of the server-side copy of GitLab CE and maybe www.gitlab.com, some large represented projects, because I know in my local testing that for certain things like partial clone, I'm not necessarily fully simulating all the work that Git has to do.
Yeah.
A much higher percentage of the objects are going to be useful.
I've thought about that. I find that if you do a mirror clone for your local tests, so git clone -- mirror, then it grabs everything that is advertised, and that is so you have the normal clone, you have the mirror clone, then you have the extra stuff that is hidden on the server. But if you grab the mirror clone, I find that you adequately, well, I don't know, but I think you have a reasonable impression of how bad things get. But yes, it would be interesting to see how bad things really are. I also suspect that in the refs, the size of the ref database, we have some really bad problems, because this is a digression, but we know that for GitLab CE, the ref database, if you do a normal clone, we advertise about 6 megabytes of refs, and a while ago we had a bug where we're accidentally advertising every possible ref in GitLab CE. That was 70 megabytes. So I suspect that we're only advertising 10% of the refs that are actually on the server, which is also, it's a different problem, but it's also would be interesting to investigate. Okay, I was going to try to create a split. So I've created a new clone, and now what I want to do in here is I want to have, I want to use alternates to create a new pack file. So I'm going to do git clone s bear dot into repack.git, and then so why am I doing this? If I do git for each ref on the current one, then you get all these weird things in their refs environments. But I did that git clone shared. If I do it there, then I only get refs heads. So this is the thing that is, I want to create a pack file, and I'm defining the pack file by creating an actual clone and saying, let's just repack that, and then we have something we can clone. And the reason for that is that Git repack is the only sane way to, or it's the easiest way to create a bitmap file, and it refuses to create a bitmap file if it thinks that there are reachable objects that are being excluded from the bitmap. So in repack.git, I've created an environment where the only reachable things are the things we care about, namely the heads and the tags. So I'm now doing a repack on that one, and this creates a brand new pack file and an accompanying bitmap. That counter has to reach 1.5 million, so that takes a while. So I'm going to create a new pack file with a new bitmap, and then I can move that into the directory with the old one, and then like in the encapsulating one, and then in that one I can do a repack and say, don't throw away this bitmap. Then you end up with this smaller bitmap pack file and a pack file that contains the rest. And then that smaller bitmap pack file is also what corresponds to what goes into a normal clone. Christian, I think you know more about everything I'm saying than what I'm saying. Have I said anything funny yet, or anything that sounds wrong?
No, I don't think so. I think it's all right.
Okay,
yeah.
Thanks. So let's see what this did. If I look in repack.git objects pack, then we have a 600 megabyte pack file and a bitmap that goes with it. And if I look in this repository that I'm modifying, we have the 1 gigabyte pack file. So now what I can do is I can go into repack.git and create a keep file. And that will prevent Git repack from deleting that file. And now I can hard link all these files, or could copy them. No, I don't want to copy them because that means literally copying. I really want to hard link them because I don't want to copy 600 megabytes of data. So I'm just going to link all these things into objects pack. And now if we look here, we have the old bitmap, the old pack that is 1 gig with its bitmap, and the new pack. And we know from experience that if we would do a clone now, then we get an error message or a warning message from Git saying, hey, there's 2 bitmaps, I don't like that. But here's the magic. Now, if I do a Git repack, then if I did this right, then because of this .keep file, Git will not throw this one away, but it will throw this big one away. Or it will take all the objects in the big one that are this 1 gigabyte file, and take the objects that are not already in this one, and just create a pack only containing that. Now this counter has to go up to 1.9 million again. And we have to do some compressing. Now this is something where I wonder if this could be a built-in thing in Git, or there is a different or a smarter way to do this in Git without having to locally create a repo, do a repack in that repo, and then throw the pack file back into the other repo. This feels like a bit like a silly dance we're doing here, but it does work because now we have the one we wanted to keep is still there, and that is 600 megabytes, and we have a 450 megabyte new pack file. So we're back at around 1 gigabyte. And this goes faster if I'm not talking. I mean, well, the repacks don't go faster, so it's not free, but we're not copying that. I think the I/O cost is somewhat is sensible. And now we want to see the simulation again on the splits. I don't know why this part is so slow, because now we're just waiting for Git to load stuff, and that takes seconds already. But we kicked into the reuse scenario, even though we have a 1.9 million objects, so we're only sending 1.5 million, so we're only sending 78% of the objects, but we still get the reuse. So this is a thing we could try and build, I think. I'm not sure. Well, the difficult thing is, of course, the problem if you make a branch unreachable. And let me try to, let's see if I can simulate that. How we do that, I should, yeah, probably if I delete the master branch, that's probably bad.
That's also not very realistic.
No, that's not realistic, but it is realistic that people force push their branch. Let me just simulate a force push. So if I do a git clone of GitLab C splits to GitLab CE, I don't know why it's talking about templates. Oh, that's because that I recompiled Git myself, and now this Git is slightly messed up. So here we have a clone, and this is the master branch, and I can just amend this.
Or you could git checkout head and then like reset head to a different commit. No, whatever. The same
well, a force push on a branch is also reasonable, right?
Yeah, yeah.
This is a force push. And now I can, sorry, Marcia, you didn't do that, it's me. What's the origin? Let's not push this to gitlab.com. No, it's not. Okay, git push origin master, that gets rejected. So we force that. This is.
So I did some experimenting with this the other day on GitHub itself, and was doing like pretty crazy stuff, which should have triggered like pretty intensive repacks if this is what they were doing. And I would push and clone immediately, and immediately still get like beautiful output in terms of like the few objects. And there's no way they could have repacked GitLab CE that quickly. So there must be something else going on. See, it's like one of one.
Yeah. Well, look at this. I was wrong. We are reusing objects. So, okay. What have we learned? I don't know what I'm talking about. Maybe it works better than I thought it did.
Can I ask a question? Like, so the main benefit of this is like, I guess the incremental benefits of this above Delta Islands is relatively small, right? Because Delta Islands means that like everything's packed into like a nice little Delta Island in the pack file. Is that correct?
Yeah, I think that this is a very good question. I think the incremental benefit is that there is some work that Git does. There's some work in deciding what goes in the pack that it skips, and it can do one big sequential read of from disk instead of having to. Because the way I understand, this is where things get a bit more hand wavy. The way I understand what Git pack objects does is that not only does it try to find the things that you want in your clone, it also tries to put them in some sort of optimal order that is optimized to make Git run faster on the client when somebody runs Git commands on there. And I think the idea is that objects that you're likely to use are packed closely together, so that if you run repeated Git commands, things are already in the page cache of your operating system. So it's trying to create a kind of locality for objects.
Okay.
So that is, yeah, I don't have a deep, like a real understanding of how hard this is, but this is an effort, loosely speaking, that Git is making, and during this reuse scenario, this doesn't happen. I think we're still getting reuse here because there must be a branch in my clone that is forked off master, and then so that master commit is still reachable. So
So one thing I did because I thought of this when I was testing the other day. So one thing I did in my fork was that I wrote a script that just sort of started deleting every single ref except master, and then rewinded master. I think it was like 2 years worth of commits, force pushed and then cloned.
But yeah, we can just delete some commits. The only problem is that
I guess rather than like delving into like the specific details of how Git handles these different scenarios, is I think one of the underlying motivations, besides making the immediate situation faster, like improving clone performance, generally is useful, is more the specific scenarios that are in the near-term horizon of more complex partial clone scenarios. One thought that had occurred to me with the naive proposal we previously had around basically creating a bundle and then like just streaming that in and then letting Git work out what's missing, was the idea that somehow we might be able to accelerate clones that are filtered by a file path, because those are quite expensive in that.
Because we're talking about two scenarios, right? So you have filtering by size, filtering and filtering by file path.
Yeah, filtering by size in my testing seems quite efficient because it's just running some sort of like size operation to work out how big each object is. And that seems surprisingly fast.
I think it might be, I think each object has a size header. So if it's doing a traditional walk where it doesn't rely on the bitmap and it has to look at each object, it can just look at the size. And probably, but it depends a bit on where your size boundary is. If it's at a point where, suppose you have a very large thing, and if it's clearly above the boundary, then Git can just not copy that. And if you have a chain of delta compressed, you have a bunch of related delta compressed objects, and if they're all too big, then Git can just walk around that. I think it gets bad if you have a delta, if you have something where you don't want one part, you have to do some decompression, and then only get something in the middle.
Yeah. So I set the boundary as low as 10 kilobytes and didn't run into issue on www.gitlab. But then perhaps there are other projects that have larger text files that are crossing that 10 kilobyte boundary.
Well, but fair enough. You've tried this, and that seems it seems that this scenario is acceptable. The thing with the file path is much more. It is much more difficult, because if you have a single, if you have a blob, you don't know what file path it is. So you need to discover objects by walking tree structures. So that, I think that means that you are not using. I guess the bitmap hash cache also doesn't help you there. The whole problem with the bitmap is that you don't have any information about. With the bitmap, lets you very quickly get information about object types and where they are in the back file and reachability, but not about the tree structure. Because if you want to discover an object, like either you find a commit and then you dereference the tree it goes to, and then you dereference the trees and the objects it goes to, and as you do that walk, you can remember everything you visited and build a structure in memory where the tree looks like this. But with a bitmap, you don't have to do all that dereferencing. You don't do that walk, so you don't get this information. And the bitmap hash cache is an optimization that's sort of orthogonal to delta islands, but has a similar impact, where you solve the problem that if you know the file name of something, you can find something else that has the same file name with a reasonable likelihood, because you just hash the entire file name to a 32-bit number, and you can find other objects that have that same file name hash. But if you're working with the prefix, that doesn't help you, because that hash doesn't let you find objects that have that start with the same directory.
Yeah.
So my very my, my loose intuitive impression here is that we would need additional data structures that give hints about what is where in pack files to do this sort of thing.
Okay. Yeah.
Christian, I'm
Some
very
sort of naive approach probably won't cut it.
well. So the thing we can do with the so suppose we have so I need to understand a little better. We're interested in the scenario of including or excluding a tree, or like we have a
The
limited.
partial clone is explicitly including.
Yeah,
So
there would
the
be
situation would be a monolithic repository that maybe has 10 different projects, and so there might be 10 different filter specs that are commonly used for each project. And so the idea is, if there's 10 common filter specs that people use for cloning, like I just want project A or I just want project B and its dependencies, given that those are like relatively well-defined and known cases, can we streamline and accelerate those situations?
Well, yeah. So I'm not just free associating on this problem.
Yeah.
If you're cloning just so let's say that these things are well known and we only optimize the master branch. I'm not sure if this is a reasonable assumption, but because for each set of objects you want to send, I guess you can afford to send too many objects. But for each of these sets of sub-trees, you want to have a pack prepared, I think. And then if somebody does a clone and they say, I only want this part of the monolithic repository, then you start with a prepared pack for that, and then you ask Git to get the rest on top of that, and then we concatenate that, and then we send that back. I think that would be the naive approach we're talking about, or were you thinking of something else?
That was, I think, roughly it.
Yeah. So one issue there is that I still don't have a good feeling about avoiding violating uniqueness constraints, although it seems to be okay if you have a bitmap covering the objects you care about. And that is a bit difficult to control. That is not always easy to control because we do update pack files and bitmaps, and it might be that we have a prepared pack file that contains an object that stops being covered by the bitmap, and then git pack objects no longer makes correct assumptions about whether it can reach it. So I'm generally a bit concerned about what I was doing in the demo with the concatenation, where we are outside pack objects, because pack objects has its own view of the repository, and it says this is the bitmap file we're using, and these are the pack files, and this is the state of the refs, and we're outside that, and we're making some assumptions. We're giving inputs to pack objects and hoping it does the right thing, and it sees the same thing that we saw.
Yeah.
Now the window for that changing because a pack file got replaced is fairly small, but
yeah, okay.
It seems fragile.
Yeah, Christian, do you have any thoughts, or are you aware of any discussions around this? I know that partial clone is still relatively early days.
Yeah, I think basically the problem is that we don't have kind of bitmaps for paths. We have bitmaps for refs, but not for paths, and that's why when you want to select objects that are in one path, it's not fast. You have to follow all the objects, and so I don't know. I, I was trying to think how that could be possible, but I think I would need to to research this more, and yeah.
So you think we could pre-compute a bitmap-like structure? Yeah, that I like how that sounds, because then Git can just do, like pack objects can do what it does now, and we can just accelerate how hard it is for it to find the things it needs.
Yeah. Yeah, there have been a lot of improvements related to those kind of things. For example, now there are
the multi-pack index?
Yeah, multi-pack index. So yeah, it doesn't. It's still for refs, but and also there is the commit graph file. But yeah, there are not all the possible indexes, and especially not for passes, and the Git objects are some kind of database, and if you don't have all the indexes, it's like a normal database. If you have a database with things that don't have an index, then it's not fast. So yeah,
that's the same problem. Yes.
Yeah,
that's a fair point. All right.
My gut feeling is also that we can probably get much better results if we're able to work inside Git instead of around Git and trying to push back objects into doing the right thing from the outside.
Yeah.
Okay. Cool. Well, thank you, Jakob, for all your research and investigation into this over the last few months. I feel like
you're welcome. I wish I had more to show for, but it's at least it. Well, I learned something, and I'm trying to share. I hope we all learn something. Yeah, is there anything else we might want to? Yeah, I recorded a separate video where I talk about the bitmap, the packfile bitmap, and the information it contains. So I have a merge request where I'm adding some analysis tools where you can take a packfile with a bitmap and extract the information in a way where you can work on it with awk or text tools and see what it's actually saying. But yeah, for this problem, I think what Chris is saying is just a much better idea, to have to add the right type of index.
Yeah, okay.
And this is also one of the nice things about Delta Islands is that compared to these sort of packfile, let's make an extra packfile approaches, is that you have just one packfile and you help Git efficiently find the things it needs. From a storage perspective, that's nice.
Yeah, I think what the fact that you found that using Delta Islands, even for repos that don't have any fork, can speed up clones already is really nice. So, and it shows that you don't need to have separate pack files or things like that. Right.
There's one other thing in this area that I don't understand well, and I think you know more about this, Chris. I wonder what is going on exactly with promiser pack files. And because the way I understand it, you also have a situation where you have multiple pack files and you have to work around an existing pack file. Is there any way we could have maybe a promiser pack file that contains a set of filtered objects, and so make the promiser pack file the pre-computed thing?
Yeah, so the promiser pack files are a way to tell Git that objects are not there, but the goal is not to have all the objects or all the SHA-1s of the objects that are not there in the promiser pack file, because, for example, sometimes we just want to tell Git that, for example, a tree is not there, and Git cannot see what this tree points to, like the blobs that it points to, or the other trees, and it's because the tree is not there. So there are probably blobs that are not there too, because they might be in those trees, but the promiser pack file will not have those not even the SHA-1s of those blobs, I think. So that was one of the goal, and it was that was discussed on the mailing list, and I think people agreed that the promiser pack file should not have everything. So, but it's true that it kind of changes the semantic of what promiser objects are and so on. But
so is the idea that the server creates a pack file that has promiser objects, and these are gaps. So pack objects is still in charge of creating one pack file response, but some things are just missing.
Yes. So yeah. So the idea would be that that when you, as soon as when you create a pack, when Git creates a pack, as soon as a pack as soon as an object is in a promiser pack file, then Git just stops trying to deep further related to this object, and just put other things in the pack file, but not goes further. Yeah. So yeah, I don't know if this relates a lot to.
Is it currently? Is it completely orthogonal to the filter stuff? Like if I do a clone with filtering on it, do I get any promiser objects, or does that have nothing to do with it?
Yeah, it has things to do with it. If the remote has all the files, all the blobs and all the objects that are needed, because in this case the remote will not will use the filter to filter everything, but the idea in case of promiser remotes is that the main remote you are cloning from might not have everything, and so you might have to ask another remote. Well, it's in the case of many promiser remotes for the things that the main remote doesn't have. So yeah, so I think it's things are could be quite complex in this case.
It sounds like it's already complex. Yes.
Yeah. And
Okay.
Sorry, I have to drop.
Yeah.
Okay.
Thanks, James.
No, thank you both.
Bye. Yeah.
Okay.
So,
yeah, maybe we can talk more about this another time, because
yeah.
I'm curious. I don't I don't understand as much as I like about all this new stuff that is happening, and I want to know more about it.
Yeah, but it's also many things are still, not merged, so they might change. And
Okay.
and yeah, and it's difficult to tell because as long as you don't have working code for everything, you don't and merge code, you cannot really see what will be okay and what will fail and things like that. For example, and especially related to performance,
Yeah.
it's when you develop things, you just do it on small repos that don't have a lot of things, and it's only after when you see how this scales with big
Yeah.
repos that you can see.
Yeah. Well, yeah, but thanks again. I think the index analogy and the database analogy is very is a very strong and compelling image, and
Okay.
yeah, and we're seeing more, and this is also the trend, I guess, we're seeing with Git, because the bitmap is an extra type of index, the hash
Yes.
cache is an extra type of index.
Yeah.
If you can call it, yeah, I guess it's an extra type of index, and then so is the commit graph.
Yeah.
So just keep adding more indexes.
Yeah, I think this is the best thing we can do.
I also think I mean, I'm not an expert on databases, but I think the main reason not to have indexes with SQL databases is that they can slow down updates, but we don't do updates in Git packfiles, and indexes themselves can take up a lot of space. But so far, only the main packfile index is the biggest.
Yeah.
They're like the .idx file, but we can't do without that one, and everything else is still smaller. So, well, very optimistically, I don't think we have a too many indexes problem yet.
Yeah. One other thing we can do is when we find that there is some redundancy in the data, we can try to compress it so that the files are smaller and it's easy to do.
Clearly, yeah. The bitmap is a very good example of that, because they use both. They use a nice bitmap compression for sparse bitmaps, and they use deltas, like exclusive OR deltas, to make all the bitmaps sparser. So, because a lot of commits, like if you have two different branches, at some point they hit the same, they are the same from everywhere. So if you do exclusive OR of that, then you get a lot of zeros all the way down to the initial commits.
Yeah.
So I think it is a very good example of smart compression using the properties of the data you're compressing.
Yeah.
Yeah. Okay.
And yeah, this, for example, I'm working on wavetable, and the wavetable format tries to exploit the redundancy to make the file format smaller, and tries to add indexes also to make things faster. So it's the same kind of thing for wavetable too.
Yeah. I think that's very exciting because of what I mentioned, where it looks like with GitLab CE, we already have uncomfortably large ref database.
Yeah.
So it would be very valuable to, and also it would be very nice because we have this problem. We've been trying to create a cache for the info refs request of the Git HTTP protocol. where the motivation is that on deployments backed by NFS, it creates too many NFS RPCs to walk all the refs using the packed refs file and the loose ref file system, because Git needs to look at the file system all the time. So all those little file system lookups are overwhelming NFS servers. And if you have a ref table that is small and more efficient, that would be, I think that would be another example of exactly what we're talking about. So we're talking about with Delta Islands, you don't need to have a pre-computed pack, or you almost don't need to, because the Delta Islands just make the existing data so much more useful.
Yeah.
And I think with ref table, we don't need a cache of the info refs response.
Yeah, probably. Yeah.
Because if it's from what I saw, it sounds so much better in terms of disk I/O that you can just get rid of that cache, and that is a very good thing, I think. So I'm just saying I'm excited about what you're working on.
Okay, thanks.
Okay, let's wrap it up. Thanks for your time.
Yes, thanks.
Have a good day.
Have a good day. Bye.
Bye.